So this is 1.3 part 2, we can call it. Sketching a piecewise defined function. So a piecewise function, it's just like graphing regular functions, but we have different pieces of it, hence the name piecewise. So we're going to jump to example 55. So we have to sketch the graph of the piecewise defined function by hand. So our graph follows this function when x is less than 0, and then we follow the function below when x is greater than or equal to 0. Just by looking at our first function, what type of graph do we have here? Just this part. What form does this look like? Slope-intercept form. So what type of graph? What is it going to look like? It's a line. So it's a linear graph. So it looks like our y equals mx plus b, which is a linear graph. So we know it's going to have the shape of a line, but in order to tell where it is exactly on our graph, we can plug in a few points. So one point that we definitely want to plug in is this number here. So we're going to start by plugging in 0. So I have 2 times 0 plus 3, which would be 3. So the first point on my graph, I plugged in 0 for x, and I got 3 for y. So my first point is 0, 3. I'm going to make a little note up here. Anytime we have less than or greater than, we're going to have an open circle. If we have less than or equal to or greater than or equal to, we're going to have a closed circle at that point. So at 0, 3, am I going to have an open circle or a closed circle? An open circle, because it's just less than. We don't have that or equal to part, so it's an open circle. So I'm going to stay at 0, go up 3, and put an open circle there. Yes. Next number we want to plug in is something that is less than 0. So what's a number that's less than 0? -1. You can plug in any number less than 0. We could plug in -3 if we wanted to. So let's plug in -1. So I have -2 plus 3 would be 1. So my point would be -1, 1. Because I plugged in -1 for x and got 1 for y. Now this point just tells us the direction. It's not going to be an open or closed circle. Our graph is going to go through this point. So I'm going to go to the left to -1, up to +1. And then since this is a linear graph, I'm just going to connect these 2 points with a straight line. If we were to have picked -2, your line would look exactly the same. And we have an arrow that goes through it because x can be anything less than 0. All right, let's look at the second piece. What do you think the first number I should plug into the second piece is? 0. Awesome. I always want to plug in the number that it gives me. So I'm going to plug in 0. So I have 3 minus 0, which would be 3. So my point here is going to be 0, 3. Do I have an open or closed circle here? A closed circle. So at the point 0, 3, I'm going to put a closed circle. So I stay at 0, go up 3, closed circle there. What's another point I can plug in? 1. Anything that is greater than 0. So let's plug in 1. 3 minus 1 would be 2. So I plugged in 1 and got 2. Now this second point just tells me the direction. So it's not going to matter if it's an open or closed circle. It's not going to be an open circle. It's just going to go through that point. That point just helps me with the direction. So I go to the right one and up 2, and then I connect these 2 points with a line. So let's take a look at 59. So this is the same thing that we just did in 55. It just has 3 parts, but that's fine. So for the first part, what number should I plug in first? I can plug in 0. So I have 0 plus 3, which would be 3. So my first point is going to be 0, 3, because I plugged in 0, got 3. Do I have an open or closed circle here? Open. Closed, because it is less than or equal to. So I have a closed circle there. So I'm going to go to my graph, put a point at 0, 3, and close the circle. What's another number I can plug in here? -1. Anything less than 0. So let's plug in -1. -1 plus 3 would be 2. So I plugged in -1 and got 2. And the second point just tells me the direction. What type of graph am I going to have here just looking at the x plus 3? What's the shape of my graph? Linear. When it's linear, we only need to plug in 2 points because we just connect those 2 points with a straight line. So let's put our second point at -1, 2, and connect our dots. So the first point that we plug in, that 0, is our starting point. The second point just gives us the direction. That's why I start at the 0 and go through the second point. Any questions on the first piece? All right, let's look at the second one. So second one, it's just 3 when x is greater than 0 but less than or equal to 2. So I want to plug in the numbers that it gives me. What happens when I plug in 0? What's my y going to be? 3. Y will always be 3. It doesn't matter what you plug in. 3 is a constant, so we're just going to have a horizontal line at 3, but it's only going to go from 0 to 2. So my first point, let's say I plug in 0, y would be 3. Is this going to be an open or closed circle? An open circle. So I'm going to go to 0 and go up 3 and put an open circle. That's why we put an open circle there, because it's not really including 0 from this piece, even though it was already closed. So if you were doing this graph in pencil, it would look like a closed circle because the blue part before. So it kind of doesn't matter that it's an open circle, but you're never going to put like a dot on top of a dot because then it wouldn't be a function. So it's going to be an open circle on top of a closed one if you have one overlapping.
Like when you say you're plugging in 0, like since it's just like a 3 comma, like really, is it just supposed to be like the points? Like if you have the 0, you just put 0, comma 3.
So then if I plugged in 2, like I don't have anywhere to plug into, but when x is 2, what's my y still? 3. So like y doesn't change here. So it's going to be a constant line, but these are just going to be our 2 points. So the 2 values for x, where we stop and where we stop, where we start and where we stop in the middle piece.
Most of that is because there's like an x in between them.
Because it tells us that these are our x values. At 2, 3, do I have an open or closed circle? A closed circle. So I'm going to go to my graph, put a closed circle at 2, 3. And then connect the 2 dots. Why do I not have an arrow here?
Because it's less than or greater than 2.
Because we have a starting and a stopping point. We have a starting and stopping number here, so we don't have an arrow. It doesn't go forever in one direction. It just starts and stops. All right, and let's look at our third piece. What's the first number I'm going to plug in here? 2. So I have 2 times 2 minus 1, which would be 3. So my point here would be 2, 3, because I plugged in 2 and got 3. Do I have an open or closed circle at this point? I have an open circle because it's just greater than. It doesn't have that equal to there, so it's an open circle. So I'm going to go to 2, up 3, put an open circle. What's another number I can plug in here? 3. Anything greater than 2, so 3 works. I have 2 times 3 minus 1, so this would be 5. So my next point would be 3, 5. And remember, the second point just tells us the direction. It's not also going to be an open circle. We go through that point and just connect our dots. So I'm going to go to the right 3, up 5, and connect my 2 dots there. All right, let's take a look at 57. So my first piece is the square root of 4 plus x when x is less than 0. So what's the first number I can plug in here? 0. So I have the square root of 4 plus 0, which would be the square root of 4, which is 2. So I plugged in 0 and got 2. Am I going to have an open or closed circle here? I'm going to have an open circle. So I'm going to go to my graph, stay at 0, go up 2, and put an open circle here. For my next point, can x be anything less than 0? Can it be negative 10? What happens when I put negative 10 in for x? You can't take the square root of a negative. So what's the smallest number that my x could be for my first point here? Negative 4. Can it be anything less than negative 4? Can it include negative 4? Yeah, it can include negative 4. So let's plug in negative 4. I take the square root of 4 plus negative 4, which would be the square root of 0, which is just 0. So I plugged in negative 4 and got 0. And we said that it can include negative 4 because we can actually take the square root of 0. Yes?
But let's say you put like negative 3 and you solve it in there, you'll still get a positive 1.
Correct. I'll show you how our graph looks. We care about like the upper restriction here. So x, the biggest number for our first piece, the biggest number that x could be is 0, because that's what it tells us. The smallest number it could be is negative 4. Can't be anything less than that. But it can be anything in between negative 4 and 0. So I'll show you how our graph looks because it'll apply for any number in between negative 4 and 0. So let's go to negative 4, 0. We put a point right there. Now our square root graph is like a curved shape graph, so it'll look like that. Now if I plugged in negative 3 on our graph, it would be some value in there. It would be 1, so it'd be 1 there. But if we plugged in negative 3, we would get a point there. We plugged in negative 4 because that's our lower restriction. That's the important point that we care about. But we couldn't plug in negative 5 because that doesn't exist. Can't take the square root of a negative. Yes. Let's do the second piece. So what's the first number I want to plug in here for square root of 4 minus x? 0. So I have the square root of 4 minus 0, which would be the square root of 4, which is 2. So I plugged in 0 and got 2. Is this going to be an open or closed circle? A closed circle, because it's greater than or equal to. So let's go to my graph. I have a point at 0, 2. Now I have to be careful here because I have another square root. So what's the biggest possible number I can plug in here? 4. I can't plug in 5 because then that would give me a negative under the square root. So I could plug in anything between 0 and 4. So I'm going to plug in 4 because I want to plug in my upper restriction and my lower restriction. So I have 4 minus 4, which would be 0. So I plugged in 4 and got 0. So that's my second point. Do you think it'll be an open circle or a closed circle here? close circle, because we can plug in 4. 4 is included here. We can evaluate it and get the square root of 0, which is 0. So I'm going to have a closed circle here. So I'm going to go to the right 4, stay on 0, put a point there. And again, my square root graph is curved, so it'll look like that. So when you're graphing square roots, you always have to check if you have any restrictions on your graph. Bless you. If you were graphing something that was linear, you're not going to have a restriction other than the ones that it gives you here. So other than these restrictions. So if it was something that was linear, you could plug in 0 and anything less than 0. It doesn't matter. But when you have square roots, that's when you have to be careful and check your restrictions. Another important thing, I'm just going to do it on this side so you guys can make a note of it. So we said when we have a function that looks like y equals mx plus b, it's going to be linear. So our graph will be in a straight line. Let's say we had an x squared graph. What's our graph going to look like? What shape? A parabola, perfect. It'll be a parabola. If your graph is a parabola, you may want to plug in more than just 2 numbers, because what if I had like a point here and a point here? You're not going to connect these two with a straight line. There's more things happening in between. So if you had a parabola, if it's an x squared function, you want to plug in more than 2 points. So plug in more than 2 numbers. Yes?
So we would plug in all the x's in between those?
You don't have to plug all of them in, but maybe at least one additional one to see how your parabola scoops. If you plug in one additional one, you still don't really know the shape, plug in another. It doesn't hurt to plug in more points. All right, we had a square root graph. So that graph kind of takes the shape of a square root. And then another important one would be like an x cubed graph, which kind of snakes like that. Now these are just the parent functions of the graph. We can have transformations applied to them where they shift or reflect or stuff like that, but it's important to know the general shape of these types of graphs.